Hello all. Welcome to this interesting video session on aphelion velocity and the perihelion velocity. So today we'll try to derive the expression for the aphelion velocity. Okay, we have the aphelion velocity and perihelion velocity. Okay, so these two things we'll try to derive it, and if you derive one, then probably you can derive the other parameter, which is perfectly okay. Now, to do that, let us consider an elliptical profile as we already used to draw in our previous lectures. So, those of are not watching my previous video, please try to have a look and to get some better insights will be always helpful for you. Okay. So, these are some of the mini lectures that I am taking. So, I request all of you to learn and uh, take some insight from those. Now, for this, we have a elliptical profile like this. Okay, now this is just assume this is going to be my elliptical profile, and you can see here you have a reference mass. Let us be a big mass, and which is being placed at one foci, and this is going to be a vacant foci. And the planetary bodies. Now let's say your planet is going to approach here, and your planet is also going to approach here at certain time interval. Okay. Now, if you see here, the distance from Sun to the planet, I will mark here. Okay, this is Sun. You have planet position. Okay, the planet, and this is also a planet position at some distance from the Sun. So, if you see here, if you mark those distances, okay, now I mark the distance. So, this is going to be my uh, the maximum distance. If you see, this is going to be the maximum distance. So, this is going to be your aphelion. Okay, in different textbook you have different terminologies. You go with aphelion, you go with apoapsis, okay, apocenter. So those things are there. So it is denoted normally by r suffix a, okay, so which is also given by a into 1 plus e. If you see from the elliptical geometry, it is been perfectly clear, is it not? Now let's say your planet is moving and moving and it is approaching to this side, to this position. So this position we already know this is going to be my perihelion, okay, perihelion, which is being denoted by r of p, which is given by a into 1 minus of e, because that is the shortest distance from Sun to the planet. So that is why we have rp and ra. Now if you see here, you have your ra plus rp. If you multiply the two terms, you are going to get 2 into a. So this is nothing but the total major axis distance of the elliptical profile. Okay, so accordingly you can derive certain expressions, and if you compare your radius of the aphelion and the radius of the perihelion, or it can be vice versa. That is what I have written here. So if you see rp by ra, now you can derive the expression like this again to have a comparative study. You can go with a into 1 minus of e divided by a into 1 plus e. Now you a and e gets cancelled off. Okay. Now that is the difference actually. See, in elliptical and other conic profiles, you have the eccentricity term here, but eccentricity is absent in case of circular orbits. Okay. Now if you substitute e here, your rp is equal to ra. That means your profile is something like a circular profile, where e is going to be equal to 0. And the sun will be here, or a earth will be there, and some satellite will be revolving around the earth. So that means your RA equal to RP is equal to simply R, which is the radius of the orbit. Okay. So these things we have already seen, or we already covered in our previous lectures in a very simple way. Okay. We are not going to any higher level. So we'll try to begin our concepts if and we haven't entered into the main lecture part. So these are all some of the fundamental concepts which you should be able to do it before you proceed to any astronomy or any astrophysics or any space dynamics course related to aerospace. Okay, so I think these will lay some foundation of your interest towards space dynamics and other astrophysics topics. Okay, so these are some of the fundamentals of physics which we already studied in your elementary schools, and I have just tried from my end to make you uplift to go to the next level. Okay, so that is the uplifting process. That is what I'm doing here. Now we can write here RP by RA. So stories apart will come with the we'll try to involve here. So RP by RA is going to be 1 minus of E pairs divided by 1 plus 6. So this is one of the important expression which you can also get from the basic geometry. And here also you can compare. Your RP is going to be very much lower because in the denominator term you have 1 plus E. Okay. I hope this is clear. Is it not? Now you need to be very careful with the derivation of the Aphelion velocities and the perihelion velocities. Okay, so in the last class we have already seen about what is the total energy of an orbiting satellite or any orbiting planet, okay, which is possessing an elliptical profile. So those things we have already seen. Now let's say we have some kinetic energy of the planet which is been orbiting around the sun, and we have the potential energy also, okay, which has been orbiting around the sun. So we are more interested uh, at the perihelion first. Okay, now the perihelion, we'll try to equate this to the perihelion total energy. So that means your kinetic energy, potential energy will yield me the total energy at the overall total energy at the perihelion. Because if you see the total energy again at the aphelion or the perihelion, it remains conserved. Okay, so this remains a constant. But what is varying is the potential energy and the kinetic energy. So once potential energy is going to vary, your kinetic energy is automatically gets varied. Okay, so that is the result which we already see. Fine. Now if you go with the total energy, which is represented by E total, which is given by your GMM by 2a. So this is going to be a bounded orbit. So this is going to be a negative sign. This one we have already derived. So your kinetic energy is basically half mv square. So here you should be careful with the v term because we are interested with the perihelion velocity. We go with half mv square p by 2. And we have the potential energy here. We have gm m divided by the radius at the perihelion rp. Okay, now this is going to be my expression. Okay, so which is pretty clear. Now your m is a common term. You can divide m on both sides, and you can, that means divide m by both sides, and also you can take gm is equal to mu. Okay, if you do these two things, your expression will be somewhat simplified. Now you go with minus mu divided by 2a, which is equal to v square p divided by 2, the perihelion velocity square divided by 2 minus of mu divided by rp. Okay, now this is a basic simple math again. Now you do the stuff. You take v square p this side, v square p by 2, which is going to be equal to, and either way you can do the stuff. It's perfectly according to you. Okay, now you have minus mu by 2a, okay, plus mu by rp. Perfect. Now you have v square p divided by 2, which is equal to, you can take mu common here and you can do minus 1 by 2a plus 1 by, now here you should be careful what is going to be your rp. So your rp is a into 1 minus of u. You can directly substitute that term, okay, instead of again rewriting it. You can go with a into 1 minus of e. Perfect. Now you take 2 this side, you get v square p is equal to 2 mu into 1 by a into 1 minus of e minus of 1 by 2a. Okay, if you do some rearrangement, you will get this, because here minus sign is there. I have put the minus sign, and the positive term I have taken as the first term. Okay, now if you simplify this expression, okay, now we are interested with the simplification now. So v square p is equal to 2 mu. You get 2a. Okay, you do the cross multiplication, which is pretty easy here. 2a minus of a, I put everything in bracket, a into 1 minus of e divided by 2a square into 1 minus of e, because it is basically a by b is equal to c by d. So ultimately you end up with ad. Okay, ad, if here plus or minus is there, okay, let's say we have plus or minus ad plus or minus bc divided by bd. So this is what I have implemented in this equation, nothing else. There is no other higher mathematics involved here. Okay, so if a by d is plus or minus c by d, then that will yield me ad plus or minus of bc divided by bd. Again, it's an elementary class level, so I don't want to further highlight on that. Now if you do here, you get v square p, which is equal to 2 mu, and you get 2a minus of a plus ae divided by 2a square into 1 minus of e. And here you can do one more simplification. You get cancel 2 here. Okay, and from here you can minus 2a minus of a is actually a, so you get a plus a by 1 minus of e. Okay, now I can write here, that means your v square p is equal to mu into 2a. So here itself we can tell 2a minus of a is a, so I write a and remaining is a. Okay, so you get a square into 1 minus of e. Now again you write here dp v square mu is equal to mu into, you take 1 a common, you get 1 plus e divided by a square into 1 minus of e. And from a and a you get 1a, the down get cancelled off. Okay, you end up with only 1a here, so you get v square p is equal to mu into 1 plus e divided by 1 minus of e. And if you do vp, then vp is going to be plus or minus root of mu into 1 plus e divided by a into 1 minus of e. So a is here. Okay, so this is my expression for the perihelion velocity. So accordingly, if you do the aphelion velocity, it's very simple here. You don't have to do again the stuff. It's you can just take the reverse of this expression. Okay, so that means your vp, your perihelion velocity, that means your vp is given by root of mu divided by a into 1 plus e divided by 1 minus of e, and your v aphelion, or the aphelion velocity. Okay, your aphelion velocity is given by va is equal to root of mu by a. Now you can go with the reverse of this. You can get 1 minus of e by 1 plus e. Okay, now you can observe here, if e is going to be 0, now let's say your e is going to be 0, your vp is equal to va is equal to v. That means this is simply but an orbital velocity for circular orbit. Okay, circular orbit. So if you compare the velocity, you can see here your vp is very much higher. Okay, your vp is very much higher than your va. Why? It is simply but your vp, the time taken will be very small. Okay, that means you know that your velocity is going to be the distance traveled by the some time or something. Now here you can see the small distance here, but we have the magnitude of the time is also very small. Okay, so that means your x by t is getting increased at the perihelion. Now if we come back in the aphelion, your distance is very much higher and you require a time also which been very much higher. Okay, here time is very less, but here time is very much high. That means your velocity at the Aphelion is also going to rise. Okay, that means you require more time to travel more distance. So likewise, your velocity is going to increase. Okay, so that is a fundamental stuff over here. And always your VP at the perihelion is going to be greater than the aphelion. Okay. Now, if you compare, also you will get a good result. If you compare here VP divided by VA, if you compare, you simply end up with 1 plus. You can do the simplification if at all you require, but you can do like this also: 1 plus E by 1 minus of E. Everything is in the root. Okay, divide by mu by A into 1 minus of E by 1 plus E. Now this will go on the top, and your 1 plus E, you get Vp by Va is equal to 1 plus E by 1 plus E power 2 halves, because half into half is always 1. So you end up with only 1 plus E by 1 plus E by 1 minus of E. Sorry, 1 minus of E. Okay. This is nothing. This is going to be half into 1 plus E by 1 minus of E half. So half times half, it will yield me a result like Vp by Va is going to be 1 plus E by 1 minus of E. Okay, so this is some comparative study which we have derived. Like, okay, so if you want to compare the two velocities, I think this expression will give you some good insights. Okay, but here also it is telling me, okay, your VP is going to be very much higher, because the lower the denominator value, you are going to get the more values. And if you take VA in this side also, your mathematically or practically your VP value is going to be increased. Okay, which satisfies this condition. Okay. Now that is what the insight I want to tell, and also we know that, okay, we already have an expression for the. I want to highlight one more point here. We want to know what is the now. Let's say we have uh, the equation for the position, which is given by r is equal to, okay, a into 1 minus of e square by 1 plus e cos theta. Okay, now let's say your theta value is going to be 180 degree. So if theta value is going to be 180 degree, you end up with minus sign. So 1 minus of e. So you have 1 minus of e square. Okay. So you go with r of theta is equal to 180 degree if you substitute here. Okay. Because this is lying on the same line. We assume that this is going on the same plane, and the angle between is again 180, which is a linear angle. Okay. Now let's say your theta is 180. That means your r theta 180 is equal to a into 1 minus of e square by 1 minus of e. Okay. So this is going to be a into 1 plus e into 1 minus of e, and you end up with a into 1 minus of e. Now you cancel the terms, and you end up with a into 1 plus e itself. Okay. That means you have r theta is equal to 180 degree. Then you get a into 1 plus e. So this is nothing but your aphelion. That means here the theta value, if you see any theta, or if you want to draw any line which has been connecting here, okay, with a theta value or something, and if this is going to reach at this position where theta is going to be 180, then that means your radius is going to be equal to the radius of the or the aphelion. Okay, so at the aphelion, your theta is going to be 180 degree, and similarly, and if you substitute theta is going to be 0 degree, your r theta is going to be 0 degree, then you're going to get a into 1 minus of e. So this is going to be this position. So here, if theta is going to be 0, so this is going to be the initial position, which is been varying from 0 to 180. Okay, if you consider rp and rf. So the radius of the perihelion, you can take the theta value is going to be 180 degree. The aphelion at theta value is equal to 180, and the perihelion is going to be 0 degree. Then likewise you can get the expression. So this is also a bit good insight whenever you try to do some derivations. Okay, so this is actually a generalized equation which we already derived. Okay, so you can go back and check my previous videos and get some insights out of it. Okay, So with that, we can wind up the session here, and thank you so much.